For thousands of years, our understanding of the universe extended to the stars and planets that we could see. As we learned to make telescopes and measure the sky, our understanding of the universe grew. And so did its boundaries. The Earth is pretty big, but the Sun is bigger, about 1 million times bigger. It only looks small because it is very far away. Earth orbits the Sun at a distance of about 150 million kilometers. But that distance is peanuts when compared to the vastness of space. Here on Earth, we can use a ruler or meter stick to measure short distances. We use miles or kilometers to measure bigger distances. But space is so big that using miles or kilometers is like using inches or centimeters to measure a road trip. Now, if we want to measure stuff in space, we need something that we can relate to on an astronomical scale. One handy measurement is the light year. But what's a light year? It sounds more like a time than a distance. Imagine a car traveling at a constant speed of 100 kilometers per hour. Now, imagine the car can keep going the same speed for an entire year. There's no stop signs, no traffic jams, and no Sunday drivers. For a whole year. There are 8,760 hours in a year. So, in 1 year, the car travels 876,000 kilometers. We could call this distance a car year. But space is big. We need something bigger than a car year to measure the really huge things. We need something fast. What's the fastest thing you've ever heard of? Well, how about light? Light is the fastest thing in the universe. Light travels 300 million meters per second. Light is made up of photons. Now imagine, instead of a car, we have a little photon traveling at the speed of light for a whole year. At 300 million meters per second, that little photon can cover about 9.5 trillion kilometers in a year. We can use other units of time for shorter distances, like light hours, light minutes, and even light seconds. For example, the distance from the Earth to the Moon is about 1 light second, which means it takes light about 1 second to travel the Earth-Moon distance. From Earth, the Sun is about 8 light minutes away. When something happens on the Sun, it takes 8 minutes for us to see it. Well, how about Saturn? It's about 10 times farther from the Sun than Earth. How long do you think it would take for light to get from the Sun to Saturn? 80 minutes! The Sun to Saturn distance is 80 light minutes. The most distant planet is Neptune. Neptune is about 3 times farther away from the Sun than Saturn. That comes out to 240 light minutes, or 4 light hours. Light from the Sun has to travel 4 hours before it can reach Neptune. Turning south, we see the constellation Centaurus. This is home to the Sun's nearest neighbor, Proxima Centauri. We're now about 4.2 light years away from the solar system, and at this distance, the Sun is just another star. "1,300 light years from our solar system, we find the Orion Nebula. This is one of the many stellar nurseries in our galaxy, a place where stars are formed from huge clouds of dust and gas. Here we can see the beginning of a new star system. In time, the star inside this cloud will emerge with a number of planets in tow. The Orion Nebula itself is about 25 light years wide. High in the summer sky in the constellation Lyra lies the Ring Nebula. This colorful ring and white dwarf at the center are all that remains of a sun-like star that has long since died. We're now leaving the confines of the Milky Way. Our galaxy is home to hundreds of billions of stars. Its spiral arms span a distance of over 100,000 light years. Our solar system is right here. But at this distance, the light from our sun is insignificant compared to its brighter neighbors. Orbiting our galaxy are a number of globular star clusters. And this one, called Messier 3, orbits the center of the Milky Way at a distance of 34,000 light years. Two and a half million light years away, we find the Andromeda Galaxy, the Milky Way's nearest relative. The Andromeda Galaxy is a spiral, like the Milky Way, but it's about twice as large, measuring over 200,000 light years in diameter. In 1996, astronomers pointed the Hubble Space Telescope at the darkest part of the northern sky. Hubble stared at that spot for 10 days, taking hundreds of pictures. The light from those pictures was combined to form this, the Hubble Deep Field. Except for a handful of foreground stars, everything you can see in this picture, every little speck, is a galaxy. Two more deep field images confirmed the first. Galaxies in every direction, billions of light years away, as far as we can see. Every star you can see is our neighbor in the Milky Way galaxy. Among the stars, we find nebulae, great clouds of dust and gas that mark the remains of old stars and the birthplaces of new stars. A little farther away, we find star clusters, and deep in space, in every direction, as far as we can see, there are billions and billions of galaxies.